Above our heads, a new arms race is unfolding in silence. Satellites stalk satellites. Lasers replace missiles. The moon becomes strategic ground. The question now is simple. Will 2026 see the first shots of a space war? In orbit, satellites no longer just observe. They maneuver, they chase, they shadow rivals in what military planners call satellite dogfights. These encounters are silent, invisible to civilians, but charged with consequence. One wrong move at 28,000 km/h could blind an entire nation. The United States, China, and Russia are racing ahead, treating space not as a shared frontier, but as contested territory. Washington is building what a golden dome, a next-generation missile defense shield using space-based sensors, interceptors, and lasers. The goal is total protection, hypersonic missiles tracked from launch to impact, threats neutralized above the atmosphere. China is also making rapid strides. Its military satellites now rival the US in number and sophistication. Some can jam signals, others can grab, nudge, or disable rival spacecraft. Russia is experimenting with electronic warfare in space and reviving Cold War concepts of orbital deterrence. Moscow sees space as the ultimate equalizer, cheaper than matching conventional firepower on Earth. The conflicts are now entering a higher realm. The moon is no longer about flags and footprints, it is about power. After China and Russia, Trump also wants to put a nuclear reactor on the moon. Nuclear reactors promise constant energy during the long lunar night. Whoever controls that power controls navigation, surveillance, and deep space logistics. Put it all together, and 2026 looks less like a Hollywood Star Wars scenario and more like a cold, calculated shadow war above the atmosphere. Dogfighting satellites, laser weapons, cyber attacks on ground stations, jamming of navigation signals, tools designed to cripple everything from banking to battlefield command. Will 2026 witness an open space war? The odds still favor deterrence, too much to lose, too much infrastructure at risk, but the more weapons and reactors we push into the dark, the thinner the line becomes between a contested domain and a shooting war in the final frontier.
There could be trillions of such objects in the cosmos. I see fragments ejected from distant planetary systems, drifting for millions of years through the galactic void. Most will never encounter another star. Some, by sheer cosmic chance, pass through our solar system. 3I Atlas is only the third that we've ever detected. When 3I Atlas first blinked onto our screens, astronomers didn't see a comet. They saw a miracle. It moved with a disturbing grace, lacking the chaotic tail of ice and dust that defines a cosmic visitor. It was an anomaly of the highest order. Within us, the global scientific community was in a state of frantic mobilization. The world's biggest telescope turned as one. From the high-altitude deserts of Chile to the orbiting Hubble Space Telescope, every lens in existence zoomed in on the speck of light. Even our lonely scouts orbiting Mars were commanded to pivot, capturing data on a scale never before seen in human history. The fascination quickly spiraled into suspicion. The data returned was haunting. 3i Atlas exhibited non-gravitational acceleration, a subtle, terrifying kick as it rounded the sun. As if it was steering. Was it a light sail, a dormant probe, or a derelict scout from a civilization that vanished 1 billion years ago? "3i Atlas's shape was wrong, the speed was impossible, and the silence was deafening." Space infrastructure were redirected for a glimpse of what many now believe is not a rock, but a craft. 3i Atlas continues its lonely journey outbound from our sun, speed gradually decreasing as solar gravity releases its grip. When it finally exits our solar system, it will travel at the same velocity it entered, back into the eternal void between stars. Another wandering fragment in a galaxy containing trillions like it.
It's the oldest question of them all. Are we alone in the universe? A cosmos so vast, so ancient, that to think we're the only ones may be the greatest assumption in human history. And in 2025, that question came roaring back, powered by sightings, science, and a new hunger for truth. Look up on a clear night. Every speck of light you see is a star, many with planets, many with moons. The silence of the cosmos is deafening, yet increasingly it feels like a prelude. Astronomers now estimate at least 400 billion stars in our Milky Way alone. Stretch that across 2 trillion galaxies and you get a universe buzzing with possibilities. If even a fraction of those stars host planets, and recent exoplanet discoveries suggest billions of Earth-like worlds exist, the statistical probability of life elsewhere becomes not just plausible, but almost inevitable. For decades, the search was quiet. Methodical radio telescopes listened. Astronomers counted exoplanets. Biologists studied extreme life forms thriving where life should not survive. Then came 2025, a year that shifted the tone. Public fascination surged. Governments declassified more data. Pilots, radar operators, and scientists spoke openly about unidentified aerial phenomena. A new name of UFOs, objects that defied easy explanation. Grainy videos went viral. US congressional hearings drew millions of viewers. Experts debated propulsion systems that seemed to ignore known physics. No clear answers followed, only sharper questions. Astrobiology added fuel to the fire. The James Webb Space Telescope detected atmospheric chemicals on distant exoplanets that on Earth are linked to life. Mars missions uncovered ancient riverbeds. Icy moons like Europa and Enceladus revealed hidden oceans beneath frozen crusts. Yet science remains cautious. Extraordinary claims demand extraordinary proof. Most UFOs likely have terrestrial explanations still unknown. But the question refuses to die. Are we early? Are we late? Or are we simply not looking the right way? In 2025, humanity did not find aliens. What it found was something equally unsettling: the growing sense that we may not be as alone or as central as we once believed.
The vast expanse of darkness, a shimmering streak of glory. India's booming space ambitions have found a hero. Astronaut Shubhanshu Shukla created history to become the first Indian at the International Space Station. Shukla's feat, as part of the Axiom 4 mission in 2025, has headlined a milestone year for Indian space efforts. India would be launching its first manned space flight in 2027. With a team comprising Prashant Balakrishnan Nair, Ajit Krishnan and Angad Pratap, Shukla will helm the Gaganyaan, India's maiden space flight mission planned for 2027. Through Gaganyaan, India aims to send the crew to an orbit of 400 kilometers on a 3-day mission. A successful voyage will put India in an elite club, making it only the 4th country to send a human into space after Russia, the US and China. As part of 8,000 tests and experiments for the Gaganyaan mission, the Indian Space Agency has completed the testing of crew module drogue parachutes. It intends to carry out 3 uncrewed missions in 2026 before launching a crewed mission the year after. Buoyed by milestones such as the Chandrayaan-3, the ISRO's efforts have acquired greater momentum.
3, 2, 1, 0.
On December 24th, ISRO's powerful LVM-3 rocket lifted off flawlessly, carrying its heaviest satellite yet. Bluebird Block 2 weighs 6,100 kilograms, making it the largest ever commercial communications satellite to be deployed in low Earth orbit. The Bahubali rocket is capable of lifting 9,200 kgs.
Close to 6,000 kg we have lifted, and this rocket, this mission, we have also brought some new developments for enhancing the payload capability, something around 150 to 200 kg payload capability. And for accomplishing the Gaganyaan mission, we have to have a capability close to more than 9,000 kg.
The SpaceX mission in January 2025 not only successfully demonstrated satellite docking, but also marked an important step for space station assembly and servicing. The Indian Space Agency also actively collaborates with private players in the country through tech transfers and facility access. The government's in-space program, a single window system, enables the partnership of private firms across missions, notably Gaganyaan. Even as India's space budget has substantially increased over the last decade, from around Rs 5,600 crores to Rs 13,416 crores, the industry still believes that more could be done. India's ambitions of setting up its own space station, the Bharatiya Antariksh Station by 2035, and a crewed moon mission 5 years thereafter, mark the country's next big foray. India's ingenuity in achieving new breakthroughs means that its imprint in space is likely to get bigger and bolder.
Beyond the Yonder, amidst the infinite darkness. Space exploration is entering an exciting new era. A remarkable lineup of missions is meant to deepen our understanding of the Moon, Mars, and beyond. At the center of this new push is the United States. It is reviving a dream last realized around half a century ago. The NASA-led moon mission Artemis II is planning its first crewed mission to test spacecraft systems in lunar orbit. 4 astronauts will orbit the moon aboard the Orion spacecraft in early 2026. The US has slingshot a pair of robotic spacecraft to Mars in November 2025. The Escapade mission explores how solar radiation strips away the tattered Martian atmosphere. The US is not alone. There are many other countries which have ambitious space launches lined up for 2026. China is unraveling the mysteries of the moon. It has made a groundbreaking discovery of the moon's two-phase temperature through its Chang'e 6 mission. Rock samples from the mission reveal that the moon's far side may not just be visually different, but also colder than its near side. The findings are expected to shed light into the moon's age and its volcanic history. China's efforts paved the way for another potential mission. While lunar samples have helped unlock solar system secrets, Martian samples could offer exciting insights into the greatest mystery: life on Mars. India is making its own foray. The country is inching towards its long-standing dream of launching crewed moon missions. In 2025, Shubhanshu Shukla became the first Indian astronaut to visit the International Space Station as part of the Axiom 4 mission.
And there they all are, waving.
It is a precursor to India's upcoming Gaganyaan human spaceflight mission in 2027 and its ambitious crewed moon mission by 2040. Following the success of Chandrayaan 3, India's landing mission on the lunar South Pole, Chandrayaan 4, is in the pipeline. By 2028, it aims to collect lunar soil from Moon's South Pole, a region believed to contain water ice. India is looking beyond the Moon. It is preparing for its first soft landing on Mars by 2030. Other countries are not falling behind either. The European Space Agency plans ExoMars rover mission to search for life on Mars by 2028. Japan aims to survey Mars moons Phobos and Deimos in 2026. Private players are making rapid strides in deep space exploration. Billionaire Elon Musk's SpaceX and Jeff Bezos' Blue Origin are racing to put humans back on the moon for the first time in 50 years. Both are building lunar landers. Musk wants to move up plans for a Mars voyage. The SpaceX chief, who has been vocal about establishing a human colony on Mars, wants to send humans to the Red Planet as early as 2029.
From Earth, space looks silent. Empty and infinite. But just beyond the skies we breathe, space is anything but peaceful. Our quest for space dominance has littered the Earth's orbit, and this is getting more dangerous by the day. Orbiting our planet are over 100 million pieces of debris, remnants of ambition, exploration, and conflict. Broken satellites, shattered rocket stages, nuts, bolts, and even peeled off paint flags. Space junk like this hurtles around our planet at terrifying speeds. More than 23,000 known man-made fragments are larger than about 10 centimeters. But there are millions of tiny pieces, which are less than a centimeter. They are hard to track. But more than their size, it's their velocity which makes them akin to flying missiles. Over the last 6 decades, more than 6,740 rockets have been launched into space, generating over 56,000 pieces of orbital debris. While many objects burn up in the atmosphere, a significant number survive re-entry, with some even falling into airspace used by commercial flights. Most of the debris sits within 2,000 kilometers of the Earth's surface in what is known as low Earth orbit. It's home to several satellites. It's used for the International Space Station and China's space station, the very area where India is planning its own permanent abode in space. Houston, we have a problem. A tiny bolt hurtling at breathtaking speed can puncture a satellite. A larger fragment can destroy it completely. Back in 2009, a retired Russian satellite, the Cosmos 2251, and an active US-based communication satellite, the Iridium 33, collided at 36,000 kilometers per hour, bursting into a cloud of thousands of pieces of debris. In November 2025, China's Tiangong space station, orbiting at over 27,000 kilometers per hour, sustained a direct hit from a speeding bullet of space debris. 3 Chinese astronauts, already 6 months into their mission, were stranded in orbit and made a risky return to Earth only after a delay of several days. Almost 40% of the space junk belongs to the US. About 28% belongs to Russia and the former USSR. And another 19% belongs to China. In contrast, India has contributed a mere 0.8% of the global space debris. Countries are now racing for solutions to whittle down the cloud of space debris. Robotic arms, nets, harpoons, lasers, and new rules for responsible launches. A cluttered orbit is not just a danger to our satellites, but threatens life on Earth.